Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Well, hello and welcome back to the Digital Enterprise Society podcast. Thank you very much for coming along on this journey because this show is designed for you. It is designed to be a resource for those who work in and around the world of PLM. Hey, the Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to co-host this show along with Craig Brown, an industry veteran and former PLM leader at General Motors. Hey, Craig, how are you today?
I'm great, Tom. Still thinking about our interview from a few days ago with Dr. Greaves. It was quite interesting.
Yeah, if you didn't hear our last episode, you can go back in the archives and check out that one because that was really informative and thought-provoking. Each week, that's what we try to do here on this podcast. We try to bring you interesting interviews and other ideas to help all of the listeners enhance and grow their careers. And that's exactly what we're going to do today. Today is going to be awesome. Today, as our guest, we have Dr. Thomas Hedberg, and he is the program manager for the Model-Based Enterprise Program at the National Institute of Strategy and Technology, also called NIST. Hey, Tom, welcome to the Digital Enterprise Society podcast.
Thanks for having me.
Hey, why don't you tell everybody who's listening a little bit about your background? Where did you come from, and how did you get to be the program manager for this program?
So I have probably an interesting story. It's a little different than most people who are at NIST. I came from the private sector, so I started off my career after graduating with an aerospace engineering degree, moving out west. I grew up in the Chicagoland area, went to school at Purdue, moved out to Arizona, spent almost a decade out there in the commercial aerospace sector. But then in the last couple of years of my time out there, I got really involved in this whole digital transformation of manufacturing and the way we design products. Started getting more involved in standards, in research around that whole topic. And one thing led to another. NIST came calling, and I said, hey, why not? Let's try a change. Uprooted the entire family, moved them across country again to the East Coast, and here I am now, about 5.5, almost 6 years later, sitting in the Washington D.C. area.
So, Tom, thanks for joining us. You and I met a few months ago in Washington at a conference called the PLM Roadmap, and I was inspired to actually hear what NIST was up to. My experience in the past with NIST had been through the car companies and various standards that are needed over there. But you hit on something that I've been thinking about this model-based enterprise, and also the need to help smaller manufacturers. So could you help explain what NIST's mission is to help what you guys have coined SMEs? Yeah,
so the one thing that NIST really focuses a lot on, or at least within the engineering laboratory focuses on, is small, medium enterprises. And I think to help those who don't maybe know about NIST as much as you do, is we have a series of laboratory programs. And so there's a couple different structures to NIST. Some people may have heard about the Manufacturing Extension Partnership. Some may have heard about the Baldrige program. But then there's also our laboratories. We're a national measurement institute, and there's several of those around. I think the biggest thing probably people may have heard about just recently is the redefinition of the kilogram and some of the SI units. That's the type of those are types of things that national measurement institutes do. But at NIST in particular, we have several laboratories. I am in the engineering laboratory, and within that engineering laboratory, we have goal areas. And smart manufacturing is one of our goal areas where my program lives. And what we try to do is we work with industry. Industry really is our stakeholder at the end of the day. They're the ones that we're trying to look at how do we provide contributions through measurement science and research to standards, to technology development that are going to help manufacturing industry. And so through that, we work with large organizations as well as small organizations in industry directly, but we also work with academic institutions and consortia. But at the end of the day, we make contributions to standards. We put out, in one particular example, work that I do is within our Smart Manufacturing Systems test bed. It's actually a series of machine tools. We have a machine shop here on NIST campus that acts like a contract manufacturer. We've networked the machines, put sensors on them, collected data. We've published several reports, guidelines, recommendations on how to do what we did and provide kind of a how-to for the SME. It's interesting in that case because one of the questions we're always asked is, wow, that must be really expensive, in the case of networking the machine tools. And we have a wide range of age of machine tools. Some are 12, 13, 14 years old, up to some that are just a year or two old. And what we found was it's actually not as expensive as people think. People think tens, hundreds of thousands of dollars. We were saying, no, thousands of dollars or just a few $1,000s. And that is really a big takeaway for the small, medium enterprises when they realize that, wow, this whole idea of digital transformation is not really as unattainable as we thought. Right? We can do some small things based on recommendations that we've put out and guidelines we've put out. Those SMEs can do some small things that actually make them more digital today or help them plug into this larger idea of an enterprise, at the top tier, those OEM, tier 1, tier 2 sort of industry players.
Yeah, and I think the fact that you've done a few experiments and you can show them a guideline, if you will, how to proceed, I think that would get a lot of them over the startup problem, right? I know they look at a company like the one I retired from and they think, holy macro, those guys have all those resources. Of course, they made their factories automated and everything else, and they've been at it a couple of decades. And, if a smaller manufacturer that maybe only have a half a dozen or a dozen engineering people, they're not even sure how to approach that, and they're afraid that it's a, multi-$100,000 investment. So it's good that you're doing that and publishing it. And you mentioned smart manufacturing and digital threads. The term digital twin is getting a lot of mileage these days, and it's also getting really confusing. I think what would you tell the small and medium enterprises about digital threads, smart manufacturing, even this notion of a connection paradox that you brought up during your paper?
So the connection paradox, just to reiterate or to review some of that from you, I think you're talking about when we were at the conference, is it's this whole idea of I just want to have all my systems talking to all my other things, my people, my computers, all talking to one another. I want them to be secure. I want them to do everything for me. Is that such a hard thing to ask for? On one hand, you're like, yeah, that should totally make sense. I should be able to, if I'm doing a handoff between a design engineer and a manufacturer, I should no doubt be able to have the information and all the requirements and all the things I as a manufacturer need from that design person flow freely to me. But the reality is, and anybody who works in industry will tell you, that's it's not as straightforward as that. And so the thing about smart manufacturing, about digital thread, digital twin, all of the quite frankly, the buzzwords that we use to describe some of the things that we do, is the first thing is there's no one size fits all, right? Context, viewpoints, as I also talked about during that conference, matter. And what I mean by that is everybody has a particular role to play. Everybody has a particular set of requirements that to some degree are unique to them. That's not to say that their needs aren't the same needs as another person or another organization, but their environments may be a little different, and that has some nuances there. And it's all the way down to there's so many ways to you purchase different types of software, connect those different software from different vendors, and so on and so forth, and they all act differently, and that drives a little bit of a difference in terms of their needs and their requirements. And so, the biggest thing from a digital thread perspective, as we say, is it's not easy, but it's needed. And what we mean by that is, as we start going through this whole digital approach, in that, and let's be frank too, manufacturing has been digital for a long time. What we're talking about is talking about this whole idea of interoperability, not just from one design tool to another design tool or CAD to CAD, but from all the different types of systems that are and tools that are used in the life cycle. But it's the fact that we have been digital for a long time, but it's about digitally transforming the processes, which still today are inherently in a majority paper-based, right? And so what we're talking about for digital thread there is that handoff between design and manufacturing, or that handoff from the design office to the sustainment office, or that field support engineer. They're not using paper records. They're not using paper instructions. They're using models. They're using 3D models. They're using workflow models. They're using digital practices to retrieve the information and knowledge they need, but also log all of their inputs and all of their things into the system. And so it's really about a fundamental shift in the paradigm of how these processes operate and the types of technologies that these processes utilize to perform.
Yeah, I really like your notion of contextual views. I run up against silos of people that have their paper processes, and I call them silos because they in fact build an organizational silo and a technology silo that makes it difficult to go off and get information from the different silos and bring them into a single view. And yet some of those roles that you talked about, like a service engineer or a enhancement engineer that's got a 20-year-old product and they want to add something to it, they really rarely go to one place. They have to go to multiple places to get everything they need, from a tool diagram to a part diagram to whatever the new requirements are. What do you think are the impediments to people using more contextual views? I mean, is it sort of my experience of just there are too many silos, or is it also something to do with tool vendors, or is it just we need another advance in technology, meaning databases or clouds or whatever? What's your view?
Yes. No,
well, of course.
No. I mean, first of all, I love that you brought the silo thing. I had a person tell me once, and there's actually a colleague here at NIST who coined this. Is it's not a silo; it's a cylinder of excellence.
Oh yeah, that's good. Cylinders of excellence. Okay, we'll keep that for a month.
Right. But to some degree, right? There's truth in that, right? And that's the best thing about about buzzwords and kind of jokes to some degree, is that there is a small fraction of truth in them. And if you think about why do those silos exist, well, it was because these systems or these tools or these processes, when they first were built for a particular purpose, and that particular purpose did not include connecting it to everything else.
That's right.
And so it's not that those systems or that cylinder or silo or whatever we want to call it is bad. It's great for the particular purpose it's built for. But now, as we've moved into new ways of doing business, new technologies coming in, we want to modernize and transform to some degree the paradigms that we work in. We're finding that there's barriers to that the boundaries of those systems are becoming barriers and challenges. And so the idea, and this goes back to that digital thread thing, the idea is you don't want to break, or at least I have not been arguing for, and this is really just a new shift in my thinking just in probably the last year, I don't want to break the silos down. I want to keep the silos there. What I want to do is cut a hole in the side of them and create a pipeline between the silos. And that pipeline, right, that interface, right, that hole in the silo becomes an interface that I connect the pipe to or connect the fitting to, and it goes to another silo. That's the digital thread piece, right, is let those systems be the experts in what they're supposed to be. And what we want to do is enhance those systems or augment those systems in a way that they can connect to other systems. And that starts what work we've been doing here at NIST around this idea of standard interfaces, right? Standardizing the interfaces between the handoffs between the functions and roles and systems that have to do something. And so going to your question about context, context is super important, but who's going to manage all of those different viewpoints, all right? And this is the challenge in it, is managing all the viewpoints at the lowest level of a manufacturing paradigm all the way up to the enterprise level and across those different domains, whether it be from design, manufacturing, quality, is not an easy task. Significant human capital. you could argue today to some point that that's what the configuration manager does. If you look at configuration management teams at large OEMs, how many people do they have and how many hours a day do they spend just chasing things down, chasing down different configurations? And then, if a regulator comes in, and especially in a regulated industry, transportation is a good example, or medical devices is another example, that regulator comes in and says, okay, show me, for this particular product or this particular part I'm holding in my hand, the manufacturing data that was used, captured in its fabrication of it, what design data was used to fabricate it, who gave the authority to do that. You spend weeks tracking that stuff down, right? And I think this is partly why root causes in things like significant transportation accidents take so long to get those reports together. I know I had an executive from automotive once tell me, it says, root cause should never take more than a couple hours. And I said, that's great for when you have a single viewpoint looking at a single machine, work cell, manufacturing cell. You're right. But when you have an entire system like an aircraft or an automobile, with a supply chain as large as we have today from these OEMs, it's not that simple, right? And so times have changed. So what we need to do is get to this idea of using things like semantic web, link data, graph theory, all of the things you hear about that the social media companies are doing, all those web technology companies are doing, is how can that sort of technology, those sort of capabilities be applied to manufacturing, right? It's how do I create that next superpower search engine for manufacturing, such that whatever system I'm in, I can run a query inside that system, whether it's a design PDM or product data management system, or I'm in my manufacturing execution system. I run a query and I get back results from my entire enterprise. That is all the systems that are connected. Mm-hmm. But that's not easy either, because who's going to do all those mappings between those systems? Those systems all have different services and APIs, right?
Yeah, so, well, that's it. Yeah, the mappings are really key. And one of the frustrating things I ran into is it's just words. People using the same word in very different ways, right? Yeah. And nobody bothered to pick up a dictionary of Webster or whatever and say, oh, this is the meaning of the word. Instead, our companies end up with their own definitions of a word, and then the silos, what did you call them? Cylinders
of excellence.
Cylinders of excellence. They can't even agree on what a word means. Well, now you put a semantic graph behind that. Well, you could probably fix it for one or two, but fixing it for dozens, it's very difficult.
I disagree, actually. I think the system, what we found with some of our early work here out of a digital thread project, and to just step back for a second, I run the model-based, or I lead the model-based enterprise program with the diverse set of project leaders and great project leaders coming from various different engineering backgrounds. We had another program, this MBE program's new, we had another program where we had a digital thread project, and that just ended. We'd run in 5-year program cycles. So we just kicked off a new program cycle. In that previous program cycle, we had the digital thread project, and we found that it is feasible to do some of this dynamic linking and dynamic addressing. And what it is it takes some of the idea of doing like putting out a Rosetta Stone out in the middle of all this. And what we basically mean by this is, instead of mapping from one system to the next and having all of these n times n minus 1 divided by 2 mappings, or even n times n minus 1, depending on how those mappings have to happen, you can get to a 2n problem where all you're doing is mapping from one system to the Rosetta Stone and back. And everybody else plugs into the Rosetta Stone. And it doesn't matter if it's multiple platforms or if it's a heterogeneous sort of vertical integrated system. Mm-hmm. If you can map to that Rosetta Stone and back, then you can start doing some of this addressing. And we've used things like the handle system, which is what runs, if anybody's ever downloaded a journal paper or looked at an academic article, you see this DOI : number dot number / something something something. That's a digital object identifier. That is a unique identifier, kind of like a cage code for those who know about it, deal with the military and defense contracting. It gives you a unique identifier for an organization, and then unique identifiers for objects in those organizations. And what it does is it gives you a persistent identifier too, so that that object can move around to systems as long as the organization updates the registry for where that object lives, just like we use our web pages today. domain name registries, right? If when you go to www.nist.gov, there's a set of servers that get routed through registries. We're talking about doing the same thing for objects. I can give a DOI dot something for an object and have persistence. Once you do that, then you're right. The ontologies or the semantics of names, people argue is my system gives part number underscore part. Your system gives it part underscore number. Those things don't match. We say garbage. How about we call it Fluffy Bunny? Everybody maps to Fluffy Bunny, and then maps Fluffy Bunny back to part number or number underscore part, and we're all happy, right? Now, again, easier said than done, but what we showed is that if we can get people to agree to those types of things, there is feasibility and scalability in being able to really cut those holes, those interfaces into those silos and really start flowing pipelines through such that you can manage all of those links, manage all of those different views. You get the big kind of corpus, the fur ball of everything that's connected, but you can quickly say, well, this is a manufacturing object. What are all the first order neighbors or the first line of neighbors for that object? And that tells you, okay, there's everything that's directly related from design, from quality for that part. Well, what if I just want material data, right? Or what if I just want something? You can start building queries that are domain and context specific just by knowing what your object is and then searching for its nearest neighbors and then mapping the path in those nodes. What we're talking about is graphs, nodes and edges at the end.
Yeah, and that's a mathematician's problem, but it's a worthy problem because the next level of quality management, I believe, and this goes beyond just quality of an existing product, but maybe quality of a product you're trying to envision, is the ability to say, oh, I can reuse these components and put them into a different product and be confident that the load cases and the way people might use it, or maybe the way people will use it that I can't even predict yet, would be still a reliable product, high quality product. So this is fascinating. It's interesting. I came to a conference, you were giving a paper, you piqued some of my interest. Now we're here talking about it. If people want to know more about what NIST and the laboratories are doing, how do they figure that out? What do you recommend?
So the easiest thing to do is just go to NIST.gov, NIST, for National Institute of Standards and Technology, .gov. And you kind of crawl across different topics on the page. Manufacturing has its own topic page. If you want to know specifically about model-based enterprise, you could probably go into your favorite search engine, type NIST, and MBE or MBE program or model-based enterprise, and we'll be able to find it. You can also search the same thing on NIST. We have a great, it actually works pretty well as the search engine on NIST. You can type in your topics and usually find them, but the NIST website's where I'd start.
Okay, great. And then maybe one last point. You and I both know Professor Hartman, and Nate and I were part of the decision to turn PLM World into the Digital Enterprise Society. How do you think the Digital Enterprise Society and what's your work with MBE, how should we work together?
There's many ways those things can happen, and this goes in general for NIST. At least I'll say for the work that I've been involved in of how we've approached it. And actually, Nate Hartman's a good friend now. He actually, a little side story, was he was my computer graphics professor when I was there at Purdue. He was just starting as I was leaving. so Nate and I have Dr. Hartman and I've stayed in touch for a while. There was funny at first when I first ran into him just a couple of years after graduation at different standards meetings and that. But as I said it early on, we work with NIST works with industry, academia, consortia. We've actually done funding with Purdue, as one example. Through our grants program, NIST is a funding agency to fund grants. But in particular, organizations like the Digital Engineering or Digital Enterprise Society, we look at that kind of like a consortia, and we've got different capabilities of things like a CRADA if you really wanted to go formal, where it's a formal kind of cooperative research and development agreement, get lawyers involved. Or we've even just said, look, let's informally work together, you have discussions like we're having here. Pick up the phone, give us a call, hey, come sit on a panel. Those are all different things that we've done, but the beauty about NIST, and I think there's a video on YouTube that NIST produced a few years ago when Pat Gallagher was our director, where he talks about NIST is not a non-regulatory agency, which positions us in a great spot for working with industry, because people can let their guard down a little bit, knowing that
Right.
We're not coming from the government to yell at them. That we really are from the government and here to help.
Right.
We want to help, and so in particular, like where I've been involved, I've worked with I've gone to PLM World when it used to be the PLM World User Conference back in the day. We were having this conversation here. I've been involved with working with industry and academic institutions who have grants with us. And we've also I've participated in consortia. There's several consortia that are set up to develop standards. The STEP standard is one of those great ones that we talk about, PETA Inc. and such. There's consortia where there's membership into that, where people get together and do actual development work. So it's really because of the beauty of what NIST is and how we're structured, and we are the National Measurement Institute of the country. There's a lot of flexibility for us to be able to work together.
Okay, well, that's great. It's been a interesting discussion. I think we could go a little longer. I might keep you on the list in the future. Podcasts have these guidelines, and I think it's time for me to hand it back to Thom. Thom, any last thoughts?
No, I actually found that very interesting, and I took a bunch of notes, and I loved the whole thing, and we touched on it a couple times. It's not a silo. It's a cylinder of excellence, and I think that happens in every single industry. So,
and we need to put little holes and make them connect.
That's right. leave the silos, but connect them through the pipes, I think is the message that most people.
A very good vision. It's easier than trying to destroy the silos and rebuild from the ground up. I spent too many decades trying to do that. So.
Well, and I think that's something that everybody in every company, in every silo that they work in, can get their hands around. And not feel threatened by. So I actually loved that analogy. And I think that's something that everyone who listened kind of probably nodded and went, oh, we could do that here. So Dr. Thomas Hedberg, thank you so much for joining us here on the Digital Enterprise Society podcast. Any last words?
Well, thanks for having me. Thanks for giving us an opportunity to talk about the program and some of the great work that the team here at NIST is doing. I may be have the title of program manager, but there's a strong team behind me that collaboratively works together to help our stakeholders. So thanks for having me. And I'll take Craig up on it. Anytime you guys want me back to come talk about our stuff, I'm not one that's short for words. So I'll be more than happy to answer the phone when you call.
Well,
okay,
we'll have you back. And thank you to everybody who tuned in and listened. You know what? Join us every single week for more thoughts, ideas, and information in and around the product lifecycle management. Hey, the Digital Enterprise Society is the place for the exchange of ideas around digital manufacturing tools. Check us out at digitalenterprisesociety.org. We'll be back next week with another interview with somebody just as interesting as Dr. Hedberg. We'll see you then.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org.